Hello, good day everybody. Can you hear me and can you see my screen share? Anyone?
Yes, we can see you. Good morning, sir. Yeah.
All right. So you can hear me, right?
Yes, sir. Yeah, we can hear you.
Yes, sir, we can hear you.
All right, thank you. Okay, my apologies, guys. I was having an issue with my internet connection. I don't know what's the problem. Uh, did any one of you face any issues at all today, like with Microsoft Teams or anything like that? I was told that like some of you also had some problems. Yeah. All in all, like my apologies. I was late. I shouldn't be, and but this is also out of my control. But still, thank you for still joining the class. It's 3:30. I just thought of canceling today's class, but I thought that canceling today's class would not be very good because I don't want you guys to lose out just because of this internet connection. And hopefully, it is resolved and it stays. I will stay connected throughout this class. So at any point, if I am disconnected or anything, do stay because I'll be back. Okay. All right. Unless I couldn't connect, and then maybe I will find another way to post a message in the class. All right. So let's take a moment to scan your attendance, and we shall resume from where we left off last week. All right. Let's begin with our class today. Okay. Before we begin, last week, we didn't have a class on Thursday because I thought on that day you might want to take a break because one thing is we are ahead of our syllabus by 1 week, actually 1 week plus. So I thought I didn't want to rush anything. I didn't want to rush into going to the syllabus because I know everyone needs a break. Last week also I was talking to one of my students and actually the student was facing like a depression problem because of online learning. So yeah, I didn't know about the problem until like I had a call with her, and then like she starts crying in the call. All right. So once again, guys, I I know I've been telling this like every single class, but just in case, if any one of you facing any kind of problem, whether is it related to the class or not, or you think you're unwell in any way, especially you're mentally, mentally not well, you think like it's too much for you to take or anything like that, please reach out to me. Please reach out to me. I will do my best to help you. I cannot promise that I will, but I might know someone or somebody that who can help you. Okay, so everything is negotiable, right? In my class, I want to make it that way. If you don't tell me, I will not know about the problem, and we can talk it out. So don't just think that everything I say is like fixed. Okay, even though I like it to be that way, everything I say is fixed is so much easier on my side. But I know because I don't see you guys, I don't know what you guys are facing. I don't know how you guys are feeling. So in online learning, that is my approach. So I don't want to force anyone to do anything that is against your own will. Okay, right. So that is one. So if you face any problem, please drop me a message, or please just drop me an email. I'll try my best to attend to you. Okay. All right. So on last week's class, we had a break on Thursday, and I also gave out a quiz on Thursday. So how is everyone doing on the quiz? Just would like to know because that quiz was on magnitude comparator, and I didn't really talk a lot about magnitude comparator in the class. Like we just mentioned, oh, magnitude comparator, and as an exercise to you guys, I told you guys to start learning about magnitude comparator, right? And I also give you one tip on how to learn anything, not just magnitude comparator, and that is YouTube. YouTube is your best friend, guys. This is the 21st century. If you ask me, what's my best teacher? I would say it's YouTube because I've learned so many things through YouTube. I've learned how to teach this class through YouTube. I've learned how to recently I learned how to create a website through YouTube. I've learned how to fix things in my house through by watching YouTube, during the MCO, right? There's like nobody can go out, nobody can come to my house, and at one point, my fan was spoiled, so I couldn't call anyone to come and repair my ceiling fan. So what I did was I watched on YouTube, I learned about the problem, and I learned how to open up the entire fan. I learned how to take things apart, and I learned to fix this one component called the capacitor. I fixed the capacitor all by watching YouTube, and now my fan is working normally. So during that time, I had no choice. I couldn't call anyone. I couldn't pay anyone even to come to my house. That is one. I also learned how to cut my hair during the MCO time. Like we have 1 year plus of the barber shops are closed. I learned how to cut my own hair, and now I don't even have to go to barbershop anymore. Like it's 2 years. My last visit to barbershop was like 2 years ago. I was like, oh my god, this is to me, you know what? This is so this is so eye-opening to me. Because why? All the videos have been on YouTube like for years and years, but I never bothered to look at it. I never bothered to learn. I never bothered to go and just watch it. And as a result, like even though it's out there, but because I didn't bother to take initiative to learn, I didn't gain any benefit, right? So it's the same thing with in my class. I really hope you guys can learn, all I have to say about the topic. Like we are learning about digital logic, we're learning about K-map, we're learning about Boolean algebra, and so on. Of course, those are very good things to learn. I highly, I really hope that you guys can learn and remember all that. But if you guys can do one more extra thing, I would say do this one. That is from my class, learn how to learn. I'm going to tell you the truth, right? As soon as this semester ends, you're going to forget everything that you learned in this class. It's sad, but it's true. I've asked all my students in the past that did you actually remember how much do you actually remember from what you learned in the class? Like a majority of them will say like, oh, actually, not much. After the final exam, everything's like poof, gone, vanished. So it's a very sad reality. So that's why what I'm trying to teach you guys in this class also is don't just take the technical knowledge of what I say in the class. That is of course good, but take the knowledge of learning how to learn. Okay, take this extra things that I'm trying to convey in the class. Okay, don't, as I was saying in the last class, right? Don't take the fish that I'm giving you. I'm giving you the fish right now. Okay, I have a lot of fish. The fish is like all this contents of this lecture. I have all this fish. I'm giving you all the fish. Don't just take the fish. I'm telling you guys, take my fishing rod, guys. Take this fishing rod, because with this fishing rod, you don't have to rely on me giving you the fish ever again. Okay, so bear this in mind. This thing, this fishing rod, this learning how to learn thing does not only apply to my class, but you can take that fishing rod and learn anything you want. Think about it. Think about how powerful this is. All right. So that is just something that I want to highlight because it was so mind-opening, eye-opening to me when I first discovered this. Okay, so enough of that. Let us continue with today's class. All right. Okay, before we start, anyone wants to say anything about the quiz? Do you find it easy or can you do it actually? I haven't checked your answers. Anyone? Or like you got stuck and you don't really know how to do it, the quiz, the magnitude comparator?
It was all right, sir.
Was all right? Oh, really?
Yeah. Like
Okay.
as you said, I just YouTube. Yeah.
Yeah, of course. Like me saying this to you guys will make me out of job like in a few years time. In a few years time, if everyone goes to YouTube, I'll be out of job. well, of course, like that is something that I hope you guys are aware. So that you guys can don't have to suffer through long roads, not knowing what is out there. So just be aware of that. All right, so let's get back to our class today, and let's continue from where we left off last week. So last week, let's see. So last week we started talking about functions of combinational logic circuit. So what are functions of combinational logic circuit? So there are few combinational logic circuit that is like readily available for us to use. So last week I believe we covered this one. We covered what are adders and what are subtractors, how are they used. Remember, we also covered on why is this useful, because by taking this combination combinational circuit, we can actually combine them in some very intelligent ways to form something larger. So for example, last week we talked about like one adder, you can combine them with another adder, and then together they perform like a larger adder. And you can keep adding this adder and combine them in many ways so that it becomes an even larger adder, like even more function. So that is the idea of combinational circuit, where you can just take it as a building block for something larger. Okay, building block. So these are building block. So we saw that binary adders can be a building block for parallel adders, and it can also be a building block for subtractor. Right? So hopefully that is clear. And I've also given you one assignment on magnitude comparator. So that is also a building block. So if you're not aware of that, like you can go to YouTube and search what are magnitude comparator good for, and how can people combine it to make it into something else. All right. So today we are going to cover this one. So we're going to talk about what is encoder and what is decoder, and how are they combinational. How are they combinational logic circuit, and how we can combine them, and how we can manipulate them and connect them and make it into something else. Okay. So what I hope you guys will remember today is that as soon as you finish this class, go onto YouTube, search this keyword, encoder digital logic. Watch 5 videos on that. I bet like you will learn everything that I teach you in this class. And not only will you learn that, I think you will learn a lot more extra as well, right? So do that. And I promise that you will gain the most from our class, on my class this semester, right? Let's talk about encoder and decoder, shall we? Let's go back to my slides over here. Okay, so, right. So let's talk about encoder and decoder. Okay, let's not look at this diagram first. So remember, once upon a time in the class, like you had a secret crush on someone in the class, and then like you want to send some kind of a secret message to that special someone, but you don't want anybody else in between like to know what you're sending. Like okay, I remember this is my like primary school. Like we didn't have mobile phones, we didn't have WhatsApp, so all we got to do at that time was like we can write letters, and then we can write it on a piece of paper, and we can pass that piece of paper on to your next person, and just say that, okay, pass it to that person, pass it to that person. But at the same time, I don't want anybody to know what am I saying, what I wrote in that piece of paper, right? I'm not sure if you guys had that experience, but I don't have this kind of experience, but I know my friend had this kind of experience, right? So say you want to pass a message to somebody, but you need to go through a middle person, and you don't want that middle person to know everything about your message. So how do you do that? That is done through these two things called the encoder and a decoder. Okay, so encoder is a device that is going to encode your message. Okay, it's going to encode your message into something gibberish that is not readable by anyone, and then once it arrives at the recipient, then that recipient will be able to decode. Okay, so on one side you have encoder, and on the other side you have a decoder. So that is very similar to how WhatsApp works. Okay, for example, like you have you over here, and you have maybe your crush over here. Okay, so or anyone, it could be your friend. Okay, I'm just putting just for the sake of an example, right? So let's say you want to send a message to your friend through WhatsApp. Okay, you want to send a message, and this message is supposed to go to WhatsApp, and then it arrives at your friend's WhatsApp. Okay, just going to draw a simple picture over here. So what happens is you type in your message, and that message can be like a secret thing, like like a treasure map or something. This treasure map, you don't want anybody to know about this treasure map. But then you start thinking, oh my God, I don't want everybody to know, but if I send to WhatsApp, WhatsApp will know what I send, right? Doesn't it make sense? WhatsApp will know, of course WhatsApp will know what I send, right? The answer is no. WhatsApp does not know what you send, because we are using, in WhatsApp, there is something called encryption. So this encryption is what enables your message to be private. Okay, this is a very high level overview of what we're going to talk about today, encoder, decoder, right? So what happens in the encryption process is that when you write your message, and then this message will go through a device or something called a encoder. Okay, it goes through a process called encoding. Okay, and then it goes to the WhatsApp server, and then when your friend receives that message, it goes through another process called decoding. Okay, the device is called decoder. Okay, so after the process of this encoding, then your original message will turn into something else that nobody can understand. Okay, so if you write a message over here, that message will turn into some kind of a symbol or sign that nobody else will know until it reaches your friend's WhatsApp mobile. Okay, so today we are going to talk about this thing. What is an encoder and what is a decoder? Of course, like the encoder and decoder that we are going to talk about applies to digital logic. It is not what is being used in WhatsApp today, but the principle still applies. Okay, so that is idea of what is an encoder and what is a decoder. So here is how it looks like. So if you are taking digital logic labs, I think there is a, I'm not sure if I remember this right, there is one module that asks you to use about the encoder and decoder, but it doesn't matter. Okay, so an encoder is, in digital logic, an encoder is a IC. It looks like this. Okay, something like this. Okay, not very pretty. Yeah, it's an IC, and then it's got this IC number over here. Okay, so it's got a few pins doing different function. Okay, so an encoder, as we can see over here on the left, consists of input and the output. Okay, so we have over here inputs. Typically, I will draw the inputs on the left and I will draw the outputs on the right. Okay, I'll draw the inputs on the left so that it's easier to understand. So immediately you see over here, the encoder has got, this encoder at least, is got 4 inputs and 2 outputs. Okay, so it's supposed to convert some information over here, okay, and into a condensed form that this has only two lines over here, right? So the relationship between the input and the output pin is 2 to the power n and m over here. Okay, for example, right now over here we have a 4 by 2 encoder. That's how we say 4 by 2. Okay, 4 by 2 encoder. Okay, I can also have an encoder that is 2 by 1. I can also have an encoder that is 8 by 3. I can have another one that is 16 by 4. I can have another one that is 32 by 5. Okay, so we can see that the relationship over here is like a 2 becomes 4. It's 2 to the power something. Okay, so 3, 8. To the power 3 is 8. To the power 4 is 16. To the power 5 is 32. So that is the relationship between the number of inputs and the number of outputs. So it's like fixed over there. Okay, so in this example, I'm showing you a 4 by 2 encoder. Okay, it means 4 inputs and 2 outputs. All right, so let's take a look at the decoder. For a decoder, it is also another chip, and it looks like this. It looks as boring as this chip over here. And a decoder is supposed to perform the reverse, okay? The reverse of what an encoder does. So an encoder encodes the message into something. A decoder is supposed to reverse that entire process. Okay. Right, let's take a look at another example, how this can be useful. Right, so imagine that I'm trying to send a message over here. So this is like me, and I'm trying to send a message from my home, and I'm trying to send this message to you guys, and you are sitting at your home. So let's draw this here. Okay, so me, and then like over here is you. So I'm trying to send a message over here, and I'm trying to I have, let's say, 4 things that I want to send. Okay, so 4 bits of numbers that I want to send. 4 information that I want to send to you. So in the most straightforward way, what I can do is I can take this 4 information, I can put a long cable from my home to your home. This long, very long cable. Okay. So if I have this long cable from my home to your home, I can send this anytime to you, right? So this is a very inefficient way to do things, right? Because what if we can condense this? What if I don't need 4 cables to send this four information to you guys? I can use something we call the encoder to do that sending. Because why? Because take a look at here, guys. So with encoder, I can condense the information like this 4 lines over here. It goes through an encoder and then you can send it through this 2 lines. So what I can do instead is I put an encoder over here and all this information goes to the encoder. And this now wire goes to the other side, which is your side, and this is called decoder, and that decoder will get back the original message. So what we're saying over here, by using this encoder and decoder, now we are able to save 50%. So originally, I need 4 wires to send this 4 information, right? But now by using this encoder, I only need 2 wires to send the same information. Okay, this is like taking an example of 4 by 2. Now imagine like if you have 8 by 3, like the amount of saving that you need, that you can that you have on the amount of cable is more. Okay, see 32 by 5 encoder, there's even more cost savings over there. So that is why people are using encoder and decoder nowadays, so that to send information much more efficiently. Okay. Right, I know like this thing sounds kind of very abstract still, but this is a very high level overview on what is encoder and what is a decoder and how does it work. Now, let's take a dive on how it works in terms of the truth table. Let's take a look at this. So this is an encoder, and this is the same encoder like we've seen just now. It's 4 by 2. Now, over here, what we are seeing is the truth table of this encoder. Okay. This is how the truth table looks like. And F0, F1, F2, F3, these are just the input. I can put in A, B, C, D, W, X, Y, Z, and anything like those are just the name. This output is also just the name of the variable. It doesn't matter. So I want to take your attention over here right now. So the truth table of an encoder and decoder looks a little bit different than the truth table that we've seen so far. Okay, let's take a look at this. So over here, we have this truth table, and this truth table only has got 4 rows. And in each row, we see that row number 1, we start over here with F0 being 1, and then the rest, F1, F2, F3, they're all zeros. Okay, the next row, we see that the only row that, the only box there's 1 is just over here, F1. So the rest, they are zeros, zeros, and zeros. And over here, the third row, we see that only here it is 1, the rest, they are zeros. Okay, over here, we see that it's only one box as 1 and the rest are all zeros. Okay, so this kind of format is known as the one hot format. Okay, it's known as the one hot format. If you're online, if you go to YouTube and when they say, oh, it's a one hot format or one hot encoding, this is what it means. It means that at one row there's only one value that is hot. Okay, hot means it's on, it's turned on. Okay, that is the language that they use. One hot. Over here, there's only one that is hot. The rest, they are cold, or there's 0. Okay, over here, there's only one value that is hot. The rest, they're not hot or they're cold. Same here, same here. Okay, that's the format. Okay, that's the input, right? Right, now take a look at the output. So in order for this 4 rows, the output will look like this. So the output can only have 2, okay, because this is a 4 by 2 encoder. Means the input is 4, the output is 2. So the output will only have two variables. So the first row we see that is 0, 0, and then 0, 1, 1, 0, and 1, 1. So that is how we write the truth table for the encoder. All right. So now let's take a look at the decoder. At the decoder, it is the opposite. Okay, it is going to take the XY and then it's going to turn back into the information. Okay, F0, F1, F2, F3. Okay, so it's going to take in over here. This is the input, and now this one, these are the output. Okay, for the decoder, that's the output, and this is the input. And for the encoder, it's the other way around. Okay, so if it gets this 0, 0 as the input, and it will give you 1. Okay, it will give you the exact information over here. Okay, 0, 0, and then it's got this 1 over here, and then it's the same thing. We are seeing the 1 hot encoding again at the decoder. Okay, so that's the truth table for the encoder and decoder. We're going to take a look at how this works in the next example. So you might be familiar already with this encoder and decoder, and this might be something that you have come across in the class, right? So what we are seeing over here is an encoder and a decoder. So over here, what we have a keypad. Okay, this keypad has got that's got 12 values over here. Okay, 12 values. But we want to connect these 12 values to an 8-segment display. Okay, over here we have the 8-segment display. So the way we do it is we take this keypad and then we put all this value. You can see over here, this one is connected to number 0, number 1, number 2, and so on and so forth. It's connected to a decimal to BCD encoder. And once it is encoded, like it becomes only 4 values. Okay. So for example, if you press in number 0, this value will be high. This value will be hot. The rest will be 0. And what's going to happen is that this A0, A1, A2, A3, they will get a value of 0 over here. Okay, so what if you press number 1? What if you press number 1? If you press number 1, then this one will be like this. Okay, oh, it's only 1 hot. And what happens over here is now it will have 1 over here. Okay, so what if you press number 7, right? You press number 7, so number 7 over here will be high. The rest all will be 0. And number 7 is 111, right? So this is the information that is decoded, okay, from a decimal value to a BCD value. And that information gets sent to the other side, and that the other side will then decode that information. If it gets this 1110, then it will decode this information so that it lights up this as number 7, like that. Okay, so this is one example where we encode and decode information, right? By on a board, right? You can actually build this project. Actually, if you are on Circuitverse, you can also try this out, right? Encoder and decoder. Okay, so that is an example application of encoder and decoder. Right, so now I want to introduce another concept to you guys, and that is the concept of enable, active high, and active low. So for all circuits, right, you have encoder, you have decoder, even adder, even subtractor. We actually have some input that we have not talked about so far, and that input is called the enable. So if you're in the digital logic lab, you might have done this already. So you might have come across a pin that is called enable. So what exactly is this enable? So enable is a pin that tells your chip over here, that IC over here, either to turn on or to turn off. Okay, so for example, we can say certain chips, when their enable is 0, then it is off. When their enable is 1 and the chip is on. Okay, so that is the function of enable, and it's actually on most chip, especially on decoder, encoder, decoder, and other combinational circuits, right? So right now we have this enable. Enable just tells you on or off. What about active high and active low? Okay, so it turns out that we can have a circuit that is like so. Okay, let's just take a look at here. So this is the truth table of this decoder, but this truth table now has an enable over here. Okay, has an enable over here. So in this truth table, when the enable is 1, then it is on, or the circuit is enabled. When the enable is 0, then the circuit is off. Okay. So this is a situation where we have a active high. Okay, we have an active high enable. So why is it active high? It's active high because the circuit is active when the value is high. Okay, over here we see that the circuit is on when the value is 1. So that's why it's called active high enable. Okay, so take a look at the truth table. So when we have the enable to be 1, it means that the circuit is functioning. Circuit is functioning over here. So when you have the circuit functioning, what we have is that when you give it the input 0 0, and it will give you the output. Okay, so this is a decoder, right? If you give it a 0 0, the output decoder will be like this. So 0001, 1. And you give it 0 1, and then the output will be 0010. So remember, it's the one hot, right? One hot decoding over here. All right. So what about active low? So active low is exactly the other way around. Okay. So there can also be situation where your circuit is active when the value is 0. Okay. So which means in active low, when you give an enable of 0, then the circuit will turn on. And when you give the enable of 1, then the circuit will turn off. So in this situation, we call this as an active low enable. Okay, right. So we have active high enable, we have active low enable. Now, we also have active high output and active low output. All right, let's take a look at what's the difference. So what we are seeing over here is active high output. Okay, this is what we're seeing over here. It is active high output. Why is it active high output? Because the output 1, it shows that the circuit is functioning. Okay, so the output is active when it is high. Okay, over here we are seeing the output is active when the value is 1. Over here as well. Okay, so the output is, when the output is 0, we know that it is not active. Okay, so what we are seeing over here is a active high enable and active high output decoder. Okay, so I hope I'm not confusing anyone here. It's very simple. Active high means 1 is enable, 0 is disable. Okay, so we can make it into the at the enable pin, you can put it 1 to be high, and then you have your circuit turned on. But what happens if you have a 0 at the enable? So if you have 0 at the enable, it means that your circuit is not functioning. Like it's not functioning, meaning to say that there's no power going to your circuit. You can imagine it that way. It's like you didn't put in the turn on your computer. You didn't turn on your computer, but you plug in your mouse, you plug in your USB keyboard, everything. It doesn't work. You wonder why? Because it's not enabled. It's not turned on. So this is what happens when you put in the value of 0 over here. So if you put in the value of 0, what happens is the decoder is off. Okay, the code is off. As a result, over here we write here X because, as you can remember, X means don't care. Okay, don't care. So don't care means no matter what value you put in here, you will not see any response at the output. So the output will be disabled. The output will be inactive. Okay, so the inactive value is 0. Okay, right? So this is active high enable, active high output decoder. Okay, clear everyone? Now, any questions so far? Let me take a drink. Okay, now let's take a look at the other way. The other way around is also possible. So we can also have a decoder that has an active low enable and active low outputs. So what's the difference? So over here, this is the truth table. It means that over here, when you give the enable of value 0, this circuit is on. Okay, the circuit is on, which means the decoder will function as usual. But the moment you give it the value of 1 over here, okay, now the decoder does not work, it does not function, and it doesn't matter what value you give over here, the circuit will not work. And that is the active low enable part. What about the active low output part? So active low output, it means that the output is active when you give a value of 0, when you have a value of 0. For example, over here we have a value of 0. Okay, this is the active output. Value of 0 here, this is the active output. The value of 0 here, and this is the value of 0. It's the opposite of the previous one. So the output 1 over here means it's not active, it's inactive. Okay, it's only active when you have a value of 0. Okay, clear? So active low enable, active low output over here. So as you can see in the last row here, when you give a value of 1, it means that the decoder is not working, and as a result, everything here is inactive. Okay, so the state is a disable state. So that is active low enable and active low outputs. So we also have over here the difference. Another thing is you can see on the diagram, we see that if you have a bubble here, and this is the enable pin, then that tells you that this is an active low enable. Okay, if you have a bubble here at the output, then this tells you that this decoder is a active low outputs. Right? So we have now active high enable, active low enable. So we have active high outputs and active low outputs. So there can be also a combination between them. We can have like active high enable, active low outputs. That is possible. And we can also have active low enable and active high outputs. That is also possible. Okay, but I will not show that because like I don't want to confuse everyone. But now I just need you guys to understand the idea and what is the concept between active high and active low. Okay, right, so that is how. All right, so with that in mind, now I am going to show you how this decoder can be a combinational circuit. Okay, so going forward, we are going to talk more about decoder because decoder has got more applications in this course. So we're done with encoder actually. So with decoder, we can actually construct by combining several decoders. Like we can make that decoder into a bigger decoder that performs more function. And with decoder also, we can actually construct any truth table. So I'll show you guys after this how we use this decoder to make any truth table, right? Right. So right now I am going to show you how we can combine multiple 2 to 4 decoders to form a larger decoder. So just now we saw that in the beginning we have a 3 by 8 decoder, right? So this is a larger decoder, and now I am showing you guys here this 3 by 8 decoder. Actually, we can make it using combination of this 2 by 4 decoder. Okay, so how we do that? Now we need to make use of the enable in that case. All right, so let's just start it this way. So this will be the input. You can imagine over here that this is the large 3 by 8 decoder inside over here. Okay, this is a 3 by 8 decoder, and inside this 3 by 8 decoder actually is a smaller decoder that is like so. Okay, so this will be the input to the decoder. There's 3 inputs, and this will be the output. There's like 8 outputs, right? Right. So if we give a value of this 0, 0, 0 to the decoder, so you would expect that 0, 0, 0 gives you a value of what? Everything 0 except for one value at the output, right? So let's take a look at what happens if you give in 0. So you get 0 here, right? Because W0 and W1 goes in here, and W0 and W1 is also 0 here. So what's different is over here we have a W2 is connected to this enable and this NOT gate over here. So over here we have a value of 1, and over here we have a value of 0. Okay, so what this means is that this value, this decoder is now turned on. This decoder is now turned off because it gets the value of 0 here. So because this value, this decoder is now off, what happens is that the output here is going to be all 0. Okay, what this decoder now is on, So which means that it's going to function as a usual decoder. So in a usual decoder, if you get 200 as the input, so what value will you produce? So you will produce this as the output. Okay. So if you take a look at the larger picture, so you have a decoder that is a 3x8 decoder. The first value, the first row in the truth table is 0, 0, 0, and then everything is 0 here except for the first output. Okay, so that is how we construct a larger decoder 3x8 by combining multiple 2x4 decoder inside here. Okay, so we can also take another example over here. Let's say we have now let's say we have 0, 0, and 1 over here. Okay, so what happens is that this one goes in, and then this now is disabled, and this W2 goes into this one, and this one is enabled. So what happens over here now? This one is off, and this one is on. This top decoder is turned off because it's off. All the values, all the outputs here will be 0. Now over here, because this decoder is turned on, now it will function as a normal 2 to 4 decoder. So in a normal 2 to 4 decoder, when you get these two values at the input, what do you get at the output? The output you'll get this. Okay, the first output will be high, and then the rest will be low. Okay, so that is how we combine multiple smaller decoders into a larger decoder. Right, so hopefully this makes sense to you. So one thing that I didn't draw properly over here is that take note over here, W0 is connected over here, and it is also connected down here, right? W0 and W1. Okay, so just to not make it look messy, that's why it's drawn in this way. W0, W1, W0, W1 over here. Okay, so that is how we combine decoders and make it into a larger decoder. Right, so as I said just now, decoder is like a magic block. It's a magic block. Why? Because by using decoder, you can implement any function. Okay, you can implement any function. So what it means is that if I give you a truth table, you can construct that truth table using just decoder. Right, so let's see how it's done. For example, now we have over here this truth table. So this truth table is, okay, I just pick a random truth table from our examples. Now we're supposed to implement this function with a decoder plus some basic logic gates. Okay, now previously in our chapter 4, we see that, okay, to implement this truth table, we can do K-map, right? From K-map, then we have, then we can simplify the circuit. And then once we simplify the circuit, we can have like a simplified equation. From that equation, we can draw the logic gate, right? That is one way to solve it. The other way to solve it is by using decoder over here. And I'm going to show you decoder is so much easier to solve it. And there are advantages with using decoders as well. Okay, first question. To use a decoder, so which decoder should I use? I have 2x4 decoder, I have 1x2, I have 3x8, I have 4x16. There's so many types of decoder. Okay, so in this situation, we are interested to use a 3x8 decoder. So why is it? So because we have our outputs, we have 8 outputs. Okay, so that's why we want to make sure that the number of output at the decoder matches the number of outputs in your truth table. Okay, because we have 8 outputs now, we have no other choice but to use a 3x8 decoder. Okay, that's number 1. Okay, so how exactly do you implement this? Okay, let's take a look at this ABC. So obviously ABC is going to go in as the input. Okay, so now if I put in ABC to be 0, 0, 0 over here, right? So what is this decoder going to give me? What's the value that this decoder is going to give me? So remember just now, 0, 0, 0 is the first value in the decoder truth table. So because of that, this one will be 1 over here, and everything else will be 0, right? Okay, so that's how decoder works. So if you change, but this is not what we want. From our truth table, we want the output F to be 0. Okay, so the output F is going to be here. We want this to be 0. when we supply a value of 0, 0, 0 at the input. So what we can do is actually very simple. We can put an OR gate over here. So what we can do is we find all the minterms, and minterms over here. So this is like minterm 1, this is minterm 7, minterm 6, and this is minterm 7, right? So over here we can also label this as minterm 0, minterm 1, minterm 2, minterm 3, minterm 4, M5, M6, M7, right? So what we can do over here is that we take all the minterms and we connect them to this OR gate. Okay, so I'm just going to connect them over here, M1 over here, okay, and M6 and M7. Just going to draw this like this and like so. Okay, and the output, that is what we're going to call it F. Okay, the output is F. So now let's take a look at what is the F. Okay, sounds like a terrible example. What's the F? Okay, what's the F for 0, 0, 0 now? Okay, so if you give it 0, 0, 0, this output here will be 1, but this is not in any way connected to F, so there's nothing connected. So the output F is only connected to this 3. Okay, as a result, F over here gets a output of 0. So that is what we want over here. Okay, right. So now let's take a look at this row. What happens if we give a value of 001? 001. So we give a value of 001, right? So we give a value of 001. The decoder now will output a value like so. Okay, because 001 is the first row in the truth table, right? Decoder will give this value. Now the rest obviously will still remain 0 because that's how the decoder works. At one time, only one output is active, and because there's only one output, but this output is now connected to the OR gate, and now your F is 1. Okay, which is what we want in the truth table. Okay, let's try something else. Let's try, let's say this one, 111. Okay, so if you put 111 over here, 111. So 111 is the last row in the decoder, right? So if you have 111, decoder will give everything 0 except for the last one, which is like that, right? So as a result, this 1 here goes into this OR gate and the rest is 0, but it doesn't matter. OR gate just cares about this value, and we have a value of 1 over here, which is what we want from the truth table. Okay, so you can try this for every row. Actually, if you try this for every row, you will find that every one here, you will get exactly like the truth table. Okay, so that is how you implement any function with a decoder. So number 1, you select the decoder based on the number of outputs. And number 2, you take an OR gate and then you connect the minterm that are high here. Okay, and that constitute your output F. Okay, clear? All right, so bear in mind, over here we have which decoder is this? This decoder is active high, correct? This is an active high. Active high enable, and there's also okay, in this case there's no enable. Active high output, because why? The output when it is active, the output shows you a 1 like this. Okay, so what happens if you have the other form of decoder, which is the active low decoder? Okay, so I actually made this a circuit over here. You can go check it out in circuit verse. Okay, we'll take a look at that after this. So what happens if you have an active low decoder? So this is the same truth table like we had just now, and this time I tell you that I want an active low decoder. So how do you use an active low decoder to implement that? So it's the same. So what we can do is we can take the minterm instead of this max term. Sorry, just now we were taking minterm. Now we can take the max term instead. Take it max term, max term, max term, max term here, and we connect all this max term to an AND gate. Okay, that's the difference. Just now we connected to the OR gate, and this time we are connecting the max term to the AND gate, and that constitutes the output F. Okay, so let's take one example, right? So let's try with 0, 0, 0. We have here 0, 0, 0. So the output in this case will be 0. Only this one is active, right? The rest will be inactive because this is a active low decoder. This one is active, and because that guy is active over here, it goes to this AND gate. Now the value of F, you get a 0. This is what we have in our truth table. Okay, so let's take the last one. So we have the last one like this, 1, 1, 1, right? So 1, 1, 1, which means everything is inactive except for this last one over here. Okay, so this last one over here will be 0, but it's not connected to anything. The rest over here, they are all connected to this AND gate. So this AND gate over here will be, this will give you a value of 1, which is this one. Okay, so if you try for every single row over here, you'll find that you would get the value of F following exactly this truth table. Okay, right. So that is how you implement any function, any truth table using a decoder. Okay, of course, like if you have a decoder, a truth table that is a larger truth table, then you need a larger decoder. Right. So now let's also take a look at something extra over here. I think this will be my last slide for today. Yeah, this is pretty much it. Second last slide. So we can also remember in the last class we did adder. So it turns out that we can also implement a full adder by using a decoder. Okay, full adder is in itself a combinational circuit. Now we can use decoder to make this full adder in itself. Okay, so this is the truth table of a full adder over here. We have A, B, and carry in, and the output is like so, C and carry out. Right. So then the first question. So which decoder that we can use? So we can use a decoder that has 8 values. Why? Because there are 8 outputs over here. So we can stick with this decoder. This decoder over here, and this decoder has got 3 inputs. So obviously these 3 inputs, they are here. And what we can do over here, so we can construct the output of S first. So what we can do is that we want to mark this min term over here, and we want to draw an OR gate over here, and this OR gate will give us S, value of sum, and we want to connect this to each of this min term 1, min term 2, min term 4, min term 7. Okay, so let's just write over here min term 0, min term 1, min term 5, 6, and min term 7. Okay, so to get this value of output S, we want to connect over here is M1. So I'm just going to connect this M1 over here, M1, M2, M3, M4. So M4, I'm just going to connect this over here, M4. Oh wait, I just missed one. This M1, this is M2, this is M4, M7, right? So I'm just going to draw this M2, and let's draw this over here, M4 and M7. Okay, so just like that, we now have this function, this output F to be constructed over here. Now we need to also construct the output for carry out. So the same thing. So we want to mark this one here. Okay, M0 over here is M3, M5, M6, and M7. Okay, so we have over here carry out, and carry out is connected to this min term M3. So okay, let me just change the pen color so that it's easier to see. Okay, so M3, M3, M5, 6, 7, M5, 6, and M7, like that. Okay, so this is connected. So Okay, so that is how we make this full adder circuit using a decoder and with some additional gates over here. Okay, so if we try to simulate, right? If you put in 0, 0, 0 at the output, so if you put in O, O, O at the output, so what happens is that for a decoder, O, O, O means that this first value will be active and the rest will be 0. So that means that this first value also unfortunately is not connected to anything at all. So S will be 0 and C also is 0. Okay, this one is not connected to anything, right? So that's what we have over here, 0. Okay, so you can try this for every value in this truth table input and you should get the corresponding output. Okay, so that is how we construct a full adder by using a decoder. All right. So yes. So this will be my last slide for today. What if I change the question a little bit? Just now we implemented this, right, using a 3x8 decoder over here. So just now I've also shown you that a 3x8 decoder actually you can construct it using a smaller decoder. Okay, it's actually a 2x4 to get decoder put together. So how can you change this 3x8 decoder into a 2x4 decoder? That is what I am trying to show you guys over here. So inside this is a 3x8 decoder, and inside you can have actually inside is a 2x4 decoder. You can connect it in this way. Okay, so the green one is okay. This A is connected to the enable. So you always want to connect the most significant bit as the enable. Okay, this one the most significant bit that you can put this into your enable, which is what we are seeing over here. A goes into the enable and also goes to the enable of the second decoder. And the trick is one enable goes through a NOT gate and the other one is doesn't go through this NOT gate. So that is how we get one decoder to be active and the other one to be inactive. Okay, so B and C they act as the input to this decoder. Okay, so B goes up and B also goes bottom. C goes up over here and C also goes to the bottom. And if you try to simulate this, if you put in 0, 0, 0 over here, you would find that you will get 0 at the output, like so. Okay. All right, so guys, that will be my last slide for today. So just now in some slides, I've shown you that you can also simulate this in Circuitverse, right? So I've done some of this simulation in Circuitverse. So let me unshare this and let me open this link. So discard this. Okay, so let me show you something really cool. So what I did was this. Okay, I had some link over here, right? You can open up this link actually. This one is saved to my user profile on Circuitverse. So if you open this link up, it will bring you to this page. So this is a decoder that I have drawn. So over here, this decoder, I have drawn this to have 3 inputs. This is the way it's drawn, and I can also play around with this. Like you have 0, 0, 0. So everything is 0. So 0, 0, 1. So this one is actually following this truth table. Okay. So let's try this. Domain. Okay, so I'm not sure if you can see this. Try to zoom in a little bit more. So this decoder is what we implemented just now, right? So I redraw this in Circuitverse and so that it's easier to see. So we have over here 0, 0, 0, and we connect this to 0, 0, 0, and then this output here connecting to the LED so that I know that whether it is high or low. So if I have 0, 0, 1, the LED should light up. So that's where the LED lights up. And I have 0, 1, 0. The LED doesn't show. And the next one, I have 1, 1, 1. Let's try 1, 1, 1. The LED should light up. Okay, this is like a little fun experiment if you want to draw it on Circuitverse. I highly encourage you guys do that because I think this is how you can learn better by hands-on. Okay, also this one I have also done this one. Let's try to open this link. Yeah, I've also implemented this adder circuit onto circuit bus. Okay, so for example, if you have like a 000 over here, 000, so both of the output they are 0. So I have 001 like that, and the top part, the sum will be 1, as is shown over here. Okay, so I encourage you guys to have fun with circuit verse, and yep, that will be the end of our class today. Any questions so far? So this will be your attendance. Okay, no question. All right, so let me know if you do have any question, or if you face any kind of problem with today's class or with any of your quizzes or any of your assessment. Right, so after this, I'll release a quiz, yet another quiz again, pertaining to what we have learned in this class. So take your time to do the quiz, and also remember that YouTube is out there. Make use of it. Make use of it. Okay, so it's actually a tool that everyone can that can give you an advantage over everyone else. Okay, because let me tell you something. Most people, they don't bother to use it to their advantage. If you are able to use that to your advantage, then congratulations, you are ahead of many people already. All right, so that is all for my class today, and I really hope that you learned something, and I will see you again in our next class on Thursday. All right, so goodbye, everybody. Take care. Thank you, sir.
Thank you, sir.
Thank you, sir.
All right.
Thank you, sir.
Hey, you're welcome.